Alrighty, in today's video, we're going to be talking about 4.1, relations and functions. Alrighty, big thing is a relation has X and Y's, meaning it has an input and output. Doesn't matter how it looks, it's just I can put a number into a function, and into a relation, and I get something out of it. And I don't even want to say numbers because I can have a relation in anything. As long as what I put in, I can get something out. There's some connection between two values or two things. Right? So typically, your X will be your domain and your Y will be your range. In a sense, I'm putting in what I call my domain into my relation, and what I get out is my range. So you would think this is your input, this would be your output. Or in other words, this is the independent variable, and this is the dependent variable, right? The Y value is going to depend on what the independent variable is. Alrighty. Other than that, what else? Oh, now to be a function, there's a few things that happens. For every X value you put in, there is a unique Y value that comes out. Okay. So again, basically meaning when I plug in an X, there is a certain Y value that comes out. The issue is if I plug in an X and I get two Y values out of it, this would be a function. This would not be a function. Because basically what that would mean is that my X repeats. So another way to write this is X cannot repeat. And it also passes the vertical line test. Which basically means if I have some type of function here, I can put lines through it and it'll only touch the graph itself one time versus, so that would be a good one. A bad one would be something like this. See, I can go through it two times right there. So this would not be a function. So X cannot repeat, passes the vertical line test. You put in an X, you only get one Y value out. Now, your Y value can repeat all day. I can put in one, get two, put in two, get two, put in three, and get two, and that's perfectly fine as long as I'm plugging in a value of X and only getting one Y value out. It's when I plug a value of X and I get multiple Y's out, that's where it fails. Alrighty, and that is pretty much it when it comes to your notes. And we already talked about domain and range. All right, so let's get into some practice. All right, we're going to be on page 232, and I want to look at number 9. We are asked for this section, for each of the following relations, determine the domain and range. So you are given 3x minus 4y equals 17. All right, so when you are trying to calculate your domain and range, you need to determine what kind of function you are dealing with. Best practice, just solve for y. So I'm going to subtract 3x. So I get negative 4y equals 17 minus 3x. And then I'm going to divide by negative 4. So then I get y equals negative 17 over 4 plus 3 over 4x. And I can look at this and I go, you know what? This looks like slope intercept. So this would be a linear equation. If you notice that right off the bat, which is what I was trying to get to, this is standard form of a linear equation. Then what you know is that the domain of all linear functions are going to be all real numbers. So you can see it with the bolded R, or they might use the infinity signs in interval notation purposes. But the domain and range of all linear functions are going to be all real numbers. All righty, let's look at number 13. So number 13 says y equals -1. I want to determine the domain and range. Again, think about the graph here. So y equals a number makes a horizontal line, right? So if this is my linear line, I just stated that they always have all real numbers. Maybe I should not have stated that. The domain is always all real numbers. That part won't change. Your typical linear functions, ones that kind of do, things like this or things like do this, that's going to be the answer. But when you have a horizontal line, the range is going to equal whatever the y value is. And the way you write it is you would have like a little set builder notation little thing here. I think they call it cursive brackets. But then that right there, that would be the set in your range. There's only one y value. All right. So domain, yes, will stay all real numbers. And I say that again. Let's look at oh, I guess you won't interface with this, but if you would ever got x equals a number, then the range would all be real numbers and the domain will be whatever the x value is. But x equals a number is a vertical line and it is not a function. It actually fails the vertical line test. All right, let's look at number 17. I feel like I got more space. The Zoom application actually looked like it updated. All right, 17, you are given a graph. I'm going to be like super accurate with this. I just need you to get the gist of this. All right, so 1, 2. So 1, 2, 3, 4, 5, 6. -2. -3, -4, -5, -6. And this would be at +2. And ooh, I just realized it was going by twos. All right, so this would actually be -1, -3, and +1. And then this would be 1, 2, 3, 4, 5, 6, 7, 8. That would be 4. All right. So as accurate as we can, when you have a graph like this and it can start and end somewhere, I usually teach this as your ceilings and floors and walls. In a sense, if you can draw a line that will contain your graph, then its domain and range will have restrictions. So for instance, your domain, oh, there's a lag. Again, I never know if y'all can see that lag or not. It's the first thing I can see when I'm trying to write, and I've written, 5 or 6 words, and it's still trying to write that second word. Sometimes the connections are good, and sometimes it's a little off. We'll get it all figured out. All right, so then the domain here will be from left to right. So my farthest left number would be -3. My farthest right number would be 1. It is a solid circle, so it would get a bracket. If you would have had open circles, then it's not part of the set. I would put parentheses. My range would be bottom to top. So the bottom happened to be 0, and the top ends up being 4. And again, it's a solid circle, so it gets brackets. So that would be a domain and range situation there as well. All right. Oh, let's do one more. Let's look at number 23. So I was talking to you about relations don't have to be numbers. It just basically means I put something in and I get something out. So when we look at number 3, it says V equals X comma Y such that X is the brother of Y. All right, so if X is the brother of Y and you need to know what your domain is, so domain deals with your X, X is the brother of Y. So in this situation, your X would represent all male, all males with siblings. Right? So to be a brother, you have to be a male, and to be a brother, you also have to have siblings. So you can be a male but be the only child. So the X here will be all males with siblings. Right? So that's your domain. So now you have to consider, all right, then what's your range going to be? What does the range represent? And in this case, if X is the brother of Y, then you would simply just say, well, it's going to be all people, because you don't know Y could be a boy or a girl. So it's all people who have a brother. So it's not going to be all the people in the world. So again, you could be an only child, but it's going to be all people who have a brother, not just people who have a sister or a sibling, but specifically a brother. So notice here, domain and range is not a number, but if I put in a male that has a sibling, then I know the range would be the sibling of that brother. All right. So again, that's just a different way to kind of look at relations there. And then also too, this could be not a function because you could be a brother of multiple siblings. So remember, when you plug something in, you only want to get one result out. So if you're a family that has 3 kids, then you're the brother, you would have 2 siblings. And I just want one answer, not multiple answers. All right, so let's look at another section. Let's look at number 32. In this section, it says determine which of the following relations is a function. And for those that are not functions, identify 2 order pairs with the same first coordinates. So again, I'm going to roughly sketch this, but here is my graph. And when you're trying to determine if a graph is a function or not, you just have to kind of draw some vertical lines and then ask yourself, can I draw a vertical line in which it will touch more than one time? And if your answer is no, then this is a function. And if it is a function, then you cannot come up with 2 points that would make it not a function. All right, so that's simple using the vertical line test. I'm not going to go into too much detail there. Let's look at number 47. So in this section, it asks us to rewrite each of the following relations as a function of x, basically meaning solve for y, and then evaluate the function at x equals -1. So on 47, you're given 6x squared minus x plus 3y equals x plus 2y. So if you're trying to build a relation of a function of x, we need to get y by itself. Now, most people like to go move the y to the left. I see that I have less stuff to move if I move the y to the right. So I'm going to subtract 3y on both sides. and subtract this x. And notice that I'm lining up all of my variables. So this gives me 6x squared minus 2x. This would go away. This would go away. Equals negative y. So if negative y equals this, I can divide or multiply everything by -1. And now I would get negative 6x squared plus 2x equals positive y. So now that you have your function of y, that's the first step. The second step now is to rewrite it in a sense that you write it as f of x. So I'm replacing y with f of x. And then I'm just going to rewrite the equation. So now you have the equation and as a relation of x. So now I'm able to find f of -1, which would be what x equals -1 means. So now I plug in -6 times -1 squared plus 2 times -1. Notice I replaced all of the x's with said value that I'm looking for. And then you just do some more operations here. -1 squared is 1. 2 times -1 is -2. -6 times 1 is -6 minus 2. So I get -8 as my outcome. All right. So hopefully that made sense. So but just in case it didn't, let's do another one. Let's look at number 49. 49 says x plus 3y over 5 equals 2. Again, the first thing I need to do is solve for y. I don't like fractions, so I'm going to multiply both sides by the denominator, which is 5. So I now get x plus 3y equals 10. Then I'll subtract x. I'm going to keep it in that mx plus b format, but it doesn't really matter here. Now I'm going to divide everything by 3. So when I rewrite this, I get -1/3 x plus 10/3. And again, I can look at that. That is my y. So then my answer would be f of x equals -1/3 x plus 10/3. And now I can look for what is x at equals -1 by writing f of -1. So in this case, that'd be -1/3 times -1 plus 10/3. So that gives me 1/3 plus 10/3, because that's what -1/3 times -1 is. And I get 11/3. All right, so hopefully, again, that was pretty straightforward. Let's look at another one. Let's look at number 53. Again, this is on page 234. So if you're looking at the graph, basically, give or take, I'll try to do my best here. And it's going by ones this time. So I'm going to kind of use the points they give me. So it's 1, 2, 3, 1, 2. So 1, 2, 3, 1, 2. There's a point here. There's a point here. There's a point here. There's a point right here. Right here. So that would be 2, 2. So 2, 2. And then 3, 2. And we got 4, 3. And then the last one looks to be like 5, 4. And again, I'm going to try my best to manipulate or draw the same graph. So it looks like it goes something like, I already messed up. So something like this, shoots back up, goes up here, goes down, goes kind of like this, comes back, then goes up, and wow, that was horrible, but something like that. The question, though, for 53 is what is the value for f of -1? So remember, this right here represents the x value. So all I got to do is go to where x equals -1, which is right here, and then find out what is the y value for f of -1. So here's x equals -1. And then I'm just trying to figure out, well, if this is my x -1, what's the y value that correlates with it? And in this case, the answer is 1. And that's it. So you just got to identify where it's at. So that was 53. I'm going to use the same thing. So let me look at 56. So 56 says, hey, what's f of x equals 4? This time, notice the number is not in the parentheses because this right here is the y. So now I'm going to go to the y, 1, 2, 3, 4. And I want to know what is the x value that corresponds with that y value. So in this case, that's 1, 2, 3, 4, 5. So that would mean that x equals 5. And that's it. So you just got to basically, you're given either the x or the y, and you just got to find its corresponding value. All right, let's look at number 59. So in this section here, you're asked to find A, B, C, D. I'm just going to do one of them, just kind of make it clear. So you're given f of x equals x squared plus 3x. And I want to do part D on this one. So I want to find out what is f of x squared. So in this case, anywhere there is an x, I'm going to replace it with x squared. So I replace things with parentheses to separate from anything that was already there. So I replaced this x with an x squared, but there was already a square. There's already a plus. There's already a 3. I replaced this x with an x squared. This helps clean it up. So x squared squared would be x to the 4th because you multiply powers raised to a power. And then this simply is just 3x squared. So that would be it. I'm just going to do one per these questions. All right, so let's look at number 62. 62 says f of x equals negative x squared minus 7. This time I want to do part B. So let's find f of x minus 1. So again, I'm going to replace any x with x minus 1. So it's going to be negative x minus 1. Again, notice I used parentheses, squared minus 7. All right, here is the misconception here. A lot of students want to say, well, this is just x squared plus 1 because they just distributed the square to the x and the 1. But this right here means x minus 1 times x minus 1. All right, so you got to fold that out. So that's going to be negative, and then that's x squared, and that's going to end up being minus 1x minus 1x. So that's minus 2x plus 1. So if you don't if you distribute and you don't actually FOIL it, you'll miss out on that middle term. So now I'm going to apply that negative. So it's going to be negative x squared plus 2x minus 1 minus 7. So again, that basically just changes all the signs and then combine like terms. So negative x squared plus 2x minus 8. That would be your final outcome. All right, let's look at another one. I'll try to, well, let me another sheet. Let's look at 65. 65 says f of x equals the square roots of 1 minus x minus 3. So in this case here, we're going to replace x with x minus 1 wherever there's an x. That square root is part of the function, so it stays. 1 stays, minus stays. Now I replace this x in parentheses with x minus 1. And now I'm outside the square root, so then minus 3. So then all I gotta do is just clean it up. So that gives me 1 minus x plus 1, because you distribute in, minus 3. And then I'm just gonna clean it up one more time. So that's gonna be negative x plus 2. You could have wrote 2 minus x. I just like the x first, but it doesn't really matter. And there you go. All right, so I feel like that's some good examples there. Let's try to make it a little bit harder. Let's look at number 70. 70 says f of x equals 6x squared minus 7x plus 3, but you're asked to find f of x plus h minus f of x over h. Just an FYI, This is a introduction to calculus with this problem here. So if that's the direction you're going, you'll see this in pre-cal, and then you'll see it again in calculus, and you'll pretty much see it in calculus 1, 2, and 3, but mainly just 1. What this does is helps us find the derivative or the slope at a certain point. By all means, y'all do not need to know that. I just wanted to show you the connection later on. What you need to do is be able to do the algebra part of this equation. So what you do first is determine what f of x plus h is. You already have f of x. It's what's given to you. You just need to determine f of x plus h. So I'm going to replace anywhere there's an x with x plus h. So that's 6x plus h squared minus 7 times x plus h plus 3. Remember, this is not distribute the square. This means x plus h times x plus h. So you do need to follow that out. So that's going to give you x squared, and then xh plus xh will give me 2xh plus h squared. I'm going to distribute all together, so I'm going to rewrite it as such. Now I'm going to distribute. That gives me 6x squared plus 12xh plus 6h squared minus 7x minus 7h minus 21. You usually cannot combine anything, so just leave it like that. You now have this portion. Now you're ready to do the entire thing. So therefore, f of x plus h minus f of x divided by h looks like this. I'm going to rewrite this as is. So 6x squared plus 12xh plus 6h squared minus 7x minus 7h minus 21. That's just this. Now, minus in parentheses the original f of x. So that's going to be 6x squared minus 7x plus 3. You might be asking, why are you using parentheses? So that I remember to take this minus and distribute it to all of it. And all of this is divided by h. All right, so let's work this out. So it's going to be 6x squared plus 12xh plus 6h squared minus 7x minus 7h minus 21. Distribute, so I get minus 6x squared plus 7x minus 3, all divided by h. Now, when I combine like terms here, I'll notice that the 6x squared cancels. I'll notice that the 7x cancels. I think that's just about it. So now I'm going to and I'm missing something, I feel like. Oh gosh, I did make a mistake. All right, so 7 can go into x and h, but you don't put it to the 3. So this should have stayed. Ooh. This should stay plus 3 because I distributed way too much. Got overeager and excited. So this would be plus 3 there. And the only reason I knew I made a mistake is because 99% of the time, all 3 of these variables or terms will cancel with their counterparts. So I knew when I couldn't cancel the minus 3, I was like, ooh, I am missing something. And then I realized I made that mistake. So all this will cancel 3. It's not 3, but it'll cancel their corresponding terms. So now I'm going to write what we have left. We have 12xh plus 6h squared minus 7h all divided by h. Right? And notice they all have an h. So that means that I can cancel an h out of every term. So now my answer is 12x plus h minus 7. And that's it. Calculus adds some more to that by finding the limit as h approaches 0, where then you would plug in 0 for h. So then we can find a equation to find the slope at any given point of this equation with 12x minus 7. Totally different conversation for a different topic. But if you're interested in calculus, I do hope you go into that field. All right, so that's that. But let's just do another one. Just make sure you have a couple examples here. Let's look at number 73. So this is going to be f of x equals 2x minus 7. Again, you're asked to find f of x plus h minus f of x divided by h. All right, so again, for starters, I need to figure out what is f of x plus h. So when I plug it in, that becomes 2x plus h minus 7. So all I got to do here is distribute. So that's 2x plus 2h, not going to go to the minus 7. And there you go. So a little bit easier when talking about linear functions here. So then when I'm doing this work, f of x plus h minus f of x divided by h, I can get what I just got. So 2x plus 2h minus 7 minus, in parentheses, my original f of x. That's 2x minus 7 divided by h. Again, distribute that negative. So it's going to be 2x plus 2h minus 7 minus 2x plus 7 divided by h. So I can see that the negative 2 will cancel and the positives and the 7s. So I'm now left with 2h divided by h. So the h's would cancel, and 2 is my final answer. All right, so let's go into a different one. Let's look at number 89. In this part, you're asked to determine the implied domain of each of the following functions. So you are given s of x equals 2x over 1 minus 3x. So to talk about the domain, the implied domain here means, is there any restrictions? And with fractions, we cannot have 0 as the denominator. So all you have to do is determine what x cannot be. You don't have to worry about factoring, canceling, nothing like that. You just have to take the denominator, set it equal to 0, and determine what x cannot be. So I'm going to subtract 1, divide by negative 3. So x equals 1/3. So that's what x cannot be. So therefore, x can be everything else. So in this situation, to write this out, make sure I write it out like as homework has it. Yeah, is interval notation. So it'd be negative infinity to whatever this value is, which in this case is 1/3. Close it with the parentheses because I don't want it to be part of it, but it can be any other number up to 1/3, just not including 1/3. And then you put union and you do 1/3 all the way to infinity. So basically what you're stating here, it's every single number except 1/3. So that would be its implied domain. All right, let's do a couple more. Let's look at number 93. Number 93 says f of x equals the square root of x plus 6 plus 1. When dealing with square roots, the only restriction you have is that this cannot be a negative number. So what you do is you set what's inside to greater than or equal to 0, because it can equal 0, it just can't be a negative. So then you just solve it. So I can see that x can be greater than or equal to negative 6. Write that in interval notations. That means that x can be anything bigger than negative 6. So negative 6 is my first number, and then infinity is anything bigger. Notice it can be negative 6, so I will give it a bracket since negative 6 is part of the answer. All right, let's look at one more. So let's look at number 94. G of x equals negative 5x squared minus 4x. Note here, this is a quadratic. So know that a quadratic roughly looks like this, and it just like a linear function, it has no restrictions to its domain. So the domain here would be all real numbers or negative infinity to infinity. All right. So linear functions, quadratics, cubic, anything that's considered to be a polynomial, which can be written with powers of integers, then it's always going to be this as the answer for the implied domain. All right, and that's pretty much everything that's in that 4.1, just talking about relations, functions, and different types of graphs. If you need more help or more guidance, please continue to reach out to me by email. Other than that, I'll see you in the next video. Bye for now.